Good morning. Thank you once again for your time. What I'm going to do in the next few minutes is sort of compared to the previous presentation, again, I'm warning you guys, I'm going to get deeply technical given that I play that role at Qualys. Just sort of provoke some thinking on what exactly is happening in the context of the whole cloud-related technologies that are coming down the pipe, container functions, and how the whole infrastructure, as we have known it for quite some time, is changing very rapidly, and the applications along with that, the deployment of the applications, and again, the roles corresponding to each of these responsibilities, the management and the life cycle of that. So again, starting with the introduction, I'm Asif Awan, CTO of Container Security. Came into Qualys through the acquisition of my startup called Layered Insight, where for 4 years, we built a comprehensive container security solution that covered the entire life cycle of containerized workloads, as well as the serverless workloads. In terms of background, over 20 plus years of experience building security products. Started as a PKI engineer, public key infrastructure engineer, have built SSL, VPN, IDP, IPS products, have done two-factor authentication, dual access badges, worked for Motorola Mobility actually, building their DRM stack. This was right before the Google acquisition. My previous startup was in the mobile security space, and now I'm into container security. So again, just to begin, a quick show of hands, how many of you out here have teams that are doing something with containers or have deployed, already deployed workloads, production workloads that have been containerized or in the form of functions or serverless? Quick show of hands. That's pretty good. I would say 20% or around 15% or so. So let me again, not just in the Silicon Valley, you know, I come from the San Francisco Bay Area, but there is a lot of buzz around containers, you know. And as I go through the presentation, you'll, for those of you who have not played with it or not dabbled with it or are not very familiar with it, again, it's, there is a lot of stuff that is happening and changing. There are a lot of terms that are getting thrown around. And so please bear with me as I go through it, and I'll try to keep it at a high level, but still try to convey the message as to what is it that all of us as security leaders should be looking for. And mark my words, this is something that we will be worrying about in the coming years if we aren't already, all right? So with that, why is it that everybody is so gung-ho about containers? You know, let me try to give my perspective. Again, I'm not talking about shipping containers. I'm talking about the containers, compute containers. So the concept of containers, those who come from a technology background know very well, has existed for a while. You know, I mean, in the poor man version of containers, chroot, you know, I mean, chroot jails have existed. BSD jails have existed for a while. Solaris zones and Linux LXC containers, you know. But what Docker did over 5 years ago was that, which is something that was very brilliant, you know, not just making changes to the operating system in terms of being able to carve out certain set of processes which could be isolated and run as so-called a logical container within the same shared operating system. They also came up with a way to package the application so that all the dependencies, okay, that an application or a portion of an application relies on could be bundled together. So think of it this way, that anything and everything that an application needs for the rest of its life cycle, for the rest of its life journey, it is all packing with itself. So in that case, all it needs is just the underlying execution environment, which is the kernel, all right? So what that leads is an interesting thing that now, wherever you take this package, the application workload, it runs and behaves exactly the same way, all right? So which leads to infinite portability, you know, which is why people, one of the primary reasons and the most important reason why people are so gung-ho about containers. As you can imagine, that compared to VMs, virtual machines, you know, containers do not have a layer of execution environment or a kernel included in them, as I just said. So once you do not have that, guess what? Now containers can spin up and go down very, very quickly. You know, compared to a VM, just to throw some numbers, a typical virtual machine takes around a minute and a half to a couple of minutes to come up. It takes almost half a minute, 30 seconds to go down. But in case of containers, it can come up sub-seconds, or in certain cases, milliseconds. Of course, it depends on the kind of workload that you're spinning up. The third thing, once again, reiterating the fact that it does not include a layer of kernel or an execution environment within each container. Now, what you can do is, on the same compute, which is one of the other reasons, once again, that companies or enterprises are looking at containers, is that using the same underlying compute, now you can pack almost 4 to 6 times as many application workloads as the case when you were packing those application workloads in the form of VMs, okay? So you can run 4 to 6 times as many containers as the number of VMs. So now, let's double click into how the application workloads, these containerized application workloads are getting deployed. So the obvious thing when containers came along, obviously, just as was the case with VMs over 15 years ago, it started with, in case of VMs, at least it was the QA guys who started trying it out, because they had to retain the same environment, you know? So it was very easy to just take a snapshot of the entire environment, cut them into a CDs or whatever, which is what we used to do, and then pop it in, and then voila, you just had the same environment, testing environment, as you had configured on the other machine. In case of containers, it's slightly different. It started with the developers getting fascinated by it for the reason that I mentioned, primarily portability, right? So in case of deployments, as containers started getting adopted very seriously, this started around 4 years ago. Some of the cutting-edge companies started deploying containers in production for the advantages, Netflix being a primary example. In fact, they went ahead and built a whole bunch of layers of infrastructure in order to manage containers. This was way before even AWS was coming up with their own Kubernetes equivalent layer, you know, ECS and so on. So again, the easiest thing was just put the containers in the VM and then start running, because the existing infrastructure is all VM-based, you know? So again, with that approach, you still have the overhead of having to manage your guest OS, your hypervisor, and so on and so forth, and you're still paying for it. So then quickly, around 2 years ago, this is when around 3 years ago or so, you know, Google launched Kubernetes, and in doing so, they pretty much screwed the happiness of Docker, you know, and their Docker Swarm with it. And Kubernetes has pretty much become the de facto standard, as we all know. And again, if you guys are planning on attending a conference, a technology conference, KubeCon is a conference that none of us should be missing in the security space, you know? And I think the next one is again, I don't have any affiliation with the Linux Foundation or KubeCon, but that's a fantastic conference, and the numbers are constantly growing for the reasons that we know. The Kubernetes has become the de facto standard for container orchestration. But even in this case, when you talk about Kubernetes, this is the term that we hear about a lot, but then managing your own Kubernetes orchestration layer is not easy, you know? Again, throwing some of the technical issues, just to highlight my point or to reiterate my point, is that how many master nodes should you be running, you know? How should you be backing up the etcd, as an example, you know, which actually maintains the state of the entire cluster? So there are a whole bunch of complexities associated with running your own Kubernetes cluster, which is why you'd see that pretty much every large public cloud service provider, you know, be it AWS or Azure or GCP, and there are a whole bunch of others, they have their own managed Kubernetes version, whether it's EKS, you know, Google has GKE, Azure has AKS. And that is primarily the reason, that is precisely the reason why all of these public cloud vendors or the service providers are offering that, given the complexity of Kubernetes. Interestingly enough, there is a third kind of service that is starting to offer, more so in the context of containers. And if you ask me, containers made it possible. Because taking a big step back, 15 years ago or so, when the concept of cloud was introduced, what was the promise of the cloud? The promise of the cloud was that, hey, business owner, you bring in your workload, and I'll take care of the rest of the infrastructure. Fast forward 15 years, right? What are we doing? We are still managing infrastructure as a service layer. Even in case of public, subscribing to the public cloud service providers, various different services, managing EC2 instances, infrastructure as a service. Now there is another layer called container as a service, and so on and so forth, But now, in the context of container now, and I don't know whether you guys have heard about these services that AWS and Google and Azure have launched. AWS was the first one to launch something called Fargate, AWS Fargate, okay? If you haven't checked it out, it is pretty cool because with Fargate, all you need to do is just take your containerized or basically application workload. The management of the underlying infrastructure is completely taken care of by AWS, okay? So now, the reason it is cool, or actually there are two primary reasons why it is really, really good. The first thing is, when you are running your containerized workloads, okay, if you are subscribing to or managing your own EC2 instances, you still have to worry about two things. The first thing is, how do you provision enough of those EC2 instances, or basically your VM instances, so that you can basically maintain the elasticity which is required from a business point of view for the application, number one. Number two, how do you optimally utilize each of those VM instances? Because going back to the first deployment scenarios, remember, containers are still being run within VMs. So you have to ensure that each VM instance has enough of the containers running in them so that typically referred to as a bin packing problem. You're packing each of those bins or those buckets enough so that you're optimally utilizing your compute, all right? So all of this is automatically done by and taken care of by AWS for you. Google, in the recently concluded Google Next conference, they launched something called Cloud Run, which is the equivalent one. Azure has had something called Azure Container Instances. So these three are services, and like I said, this truly fulfills the promise of the original promise of the cloud, which is that of bring in your workload, I'll take care of the entire infrastructure management for you, okay? Of course, at a cost. But as you can imagine, from a security point of view, especially those of us who are used to installing host agents and so on, that is not going to work, right? I mean, because of the fact that you cannot say that, hey, Amazon or AWS or Google, I'm delegating the responsibility of managing the infrastructure to you, but at the same time, I'm going to muck with and start installing some agents. They'll say, get the heck out of here, If you want to do it, go ahead, use ECS, maintain your own EC2 instances, and so on, So obviously, there is no access to infrastructure. The other way to look at it is an infinite compute fabric, which is being shared across all the applications, across all the tenants, okay? So which is why you cannot tap into and install anything in that infrastructure layer. So now, to sort of bring the discussion back up, so what's happening to the application? What is the state of the application? Obviously, as you can imagine, with the agility and the portability that containers bring, the CI/CD pipelines or the DevOps pipelines are getting more and more accelerated, further accelerated, which is why you hear of GitHub and Lyft and Uber, such companies, right, deploying features, whether it's for A/B testing or for just enhancing or fixing bugs or whatever. They are making releases multiple times, not just in a month, not just in a week, but at times, multiple times a day, okay? So the CI/CD pipelines are getting faster and faster. The concept of application perimeter, as you know, because of the fact that the interesting thing that containers also brought about, unlike in the case of VMs, in case of VMs, you just take the application, which was running on a bare metal operating system, put it in the VM, and it would run without any problems, right? In case of containers, so as developers are looking at creating a new kind of workload, which is the containerized workload, all right? They're also taking an opportunity, the development teams, to look at, hey, what portions of this application can I carve out into so-called microservices, or some common services? And of course, the applications, the greenfield applications that are being built from scratch, they are being built following 12-factor and already architected in such a way so that there are certain microservices that are carved out so that you are reusing those services for putting together a set of functionality, all right? So the concept of, again, from a security point of view, one of the key things to think about was that VMs blew away the data center perimeter. What containers are doing is that they are blowing away, or they have already blown away, the application perimeter. Because you cannot take your pencil or a pen and draw the boundary around a classic n-tiered application or even a service-oriented architecture-based application. Okay? Here, there are a bunch of microservices which are serving a whole bunch of different applications, and things are very dynamic in terms of relationship, in terms of dependencies and reliance, and so on. And like I said, again, containers and the whole infrastructure being built around containers is what is leading to the likes of, obviously, AWS Lambda, Google Cloud Functions, Azure Cloud Functions, and so on. That you can not just have your application functionality be packaged in the form of VMs, which was happening yesterday and today, or in the form of containers, but also in the form of functions. So again, now let's look at what's happening to the infrastructure. So as I mentioned earlier, when the application or a portion of an application is carrying all that it needs for the rest of its lifetime, then the dependency or the reliance on the underlying infrastructure becomes very, very minimal. So now, which is why the operating system that is used for running containers, they are very thin and very minimal, which is why you have things like CoreOS. You have Google's container optimized OS, or AWS launched something called Firecracker. So these are, think of them as just a very thin layer of just the kernel. You don't need bulky operating system distribution, the classic SUSE or Red Hat Linux and so on and so forth. So once it becomes very thin, guess what? From a management point of view, you can just treat it as immutable. Rather than patching the shared libraries, you're updating them, you can just rip and replace. So when you look at the infrastructure, again, 3 key points to remember. It is getting much, much thinner, all right? It is being treated as immutable. It is being, from a management point of view, it is just being replaced rather than being patched. And like I said, the entire infrastructure, if you ask me, is getting pushed into the background. Again, I'm going to make a very bold statement here, but I think another 5 to 7 years, if my gut is right, we will not even be talking about the operating system as we know it, Linux and all that. All we'll be talking about is Kubernetes. Okay, Kubernetes is the new Linux. What Linux did to VMs, Kubernetes is the current and the future. So anything and everything that is being built, okay, for the future is being built taking Kubernetes into consideration in terms of containerized workloads, in terms of function workloads, which is why, by the way, KubeCon is important. So now let's map it to, with all of these changes happening, how are the teams catching up with this? How are the roles mapping to the state of applications and infrastructure? So the first two, as you can imagine, that of application developers who are responsible for building the application functionality or the business functionality, that is not going to change, right? But at the same time, and this is where I sort of disagree a little bit with the previous presenter regarding a response to one of the questions, is that I've been a security application developer as a security developer for quite some time. One of the things that I've experienced personally, working very closely with the development teams and being an engineer myself, is that the application developers are never going to be good at security and are never going to be good security engineers, okay? They are good at certain things. They're really good at basically understanding the application stack or how the business functionality needs to be addressed, okay? But when you ask the same set of guys to start focusing on, hey, which OpenSSL SDK version should we be using? How should we be managing keys? Okay, public keys, what should be the management of the life cycle of the certificate? Should I even be using a self-signed certificate? None of that, it just goes over their head, And so application developers, I mean, I'm talking about the classic application developers, I think it's best to have them focus on building the business functionality. Infrastructure operators, again, in the context of Kubernetes and so on, these are the guys who are responsible for spinning up and managing the Kubernetes clusters. And if you're subscribing to a public cloud service provider's Kubernetes offering or their infrastructure offering, then all they do is basically configuring. Then the team is obviously much smaller, and they are responsible for configuring and the compliance of that infrastructure. The third one is what is interesting, and the way in the context of the state of the application and the infrastructure, this particular role has come about is, I like to call it that of application operators. What it means is that when you are building an application, okay, so application developers, they build the application workload. Let's just say they have created a whole bunch of container images. Now, the infrastructure guys have the infrastructure ready. But you still, again, getting into the details of Kubernetes, you still have to define how should this application be robust enough to handle the load, you know? How should it be highly available? And also the security, meaning in the context of Kubernetes, again, what should be the ingress controller? How should it be configured? Should I be doing network microsegmentation at layer 7 or layer 3, layer 4? So on and so forth. How should I be managing the shared secrets? You know, should I be using a HashiVault, or should I be using or should I be using the secrets just in etcd? So on and so forth. So once again, it's the application guys. They build and they build the business functionality. They package it, okay. But then what's happening is that they hand it over to these application operators who define the key aspects of the performance and availability and the security of the application. Again, not to be confused with the security and the high availability of the infrastructure, which is something that, as we know, that role has existed, and it is starting to morph, again, in the context of containers and functions, to managing the setting up and managing the entire infrastructure for running containers as well as functions. So again, so what should we do from the perspective of aligning the security roles with the way things are starting to change, and these roles have come about in the context of application development, application operation, and infrastructure. So like I said, again, I personally don't believe in having the additional responsibility be put on the guys who are really good at doing something, you know. So let them do what they are really good at doing, but at the same time, in terms of configuring the team, again, this is something that we have been doing and we have been doing successfully, is that to have an application focus, somebody who understands the security very well, be aligned. And again, when we talk about security, infrastructure security guys are not going to be as good as somebody who understands the application operation security. As an example, right? Somebody who knows how to maintain the EC2 instances of virtual machine, the entire life cycle of it, the patching of it, and so on and so forth, will not be good or will not be that good at picking up all the details of what do I need to do with Kubernetes? How should I be addressing the scalability of the application? How many replica sets should I be running? Should I be running daemon sets or not? How should I maintain the state of the application? What sort of stateful set? So again, there is a lot that is coming down the pike in the context of Kubernetes, in the context of other layers, Istio, service mesh, and so on and so forth, in terms of microservices-based applications that need to be managed. So all of that falls under the category of application operators who understand, who are still looking at the application workloads as a black box, but they have a very good understanding of these new layers of infrastructure that are getting added. You know? So from that perspective, my recommendation is that, again, have how many ever, depending on the size of the team, few security-focused guys who are responsible for looking at security from the perspective of the responsibility of that particular but the responsibility of that particular team. So in case of application security, just to double click on that, the security focused guys would typically be responsible for the source code analysis, the dynamic application security testing, the vulnerability related management, all of that. On the infrastructure security side, this is, like I said, the classic guys. If you're managing and spinning up your own Kubernetes clusters, then these would be the ones who would be responsible for maintaining what version of Linux we should be running, whether they are patched or not, the vulnerability management, so on and so forth. If you're subscribing for such a service, if you're subscribing to AWS for such a service or any of these public cloud service providers, then accordingly, checking that the configuration or the stack that the public cloud service provider is providing is compliant with your requirements, And then finally, the deployment security, like I said, as new layers are getting added to your infrastructure, be it Kubernetes, again, since I'm talking about the infrastructure multiple times in the context of containers, what has happened is that starting from the bottom of the stack, you have the classic Linux or basically the operating system as a layer or the infrastructure as a service layer. Then you have the container engine, be it Docker engine or in a small percentage, it could be Rocket or whatever, the container engine. And then you have the orchestration layer for managing the lifecycle of containers. And again, if you have very sophisticated applications which are built on microservices, and you already have an set of applications which are interacting with each other in the form of a service mesh, then you have the likes of Istio and Linkerd and so on forming the fourth layer. So once again, you start with the infrastructure as a service layer, container engine, and then on top of that, you have the orchestration, Kubernetes orchestration layer, and finally Istio on top. And that was my presentation. Happy to take some questions. I think I've got 3 to 4 minutes.
Any questions? Yes. Oh, I'll be right over.
Grant Jacoby, Deputy CISO at Fifth Third Bank. Building our application security program, it felt for the IT when we did that, I was on the IS, I went to work for the IT side, then I came back to IS to build the application security program. And I know that the developers felt the tail was wagging the dog when we were explaining how to build security in. So I guess I'm struggling. I liked everything you said, but I struggle a little bit on the purity of keeping application developers just building the application, because they, from grassroots up, are seeking how to build security, and they want the acumen, and they like having an application security champion with them. So just like learning how to build containers and going to the cloud, they're already, by virtue of that, picking up some security acumen, but they want more of it. So I guess I would question why you would keep them purist and not have more of a DevSecOps rather than just DevOps mentality.
Excellent question. And again, before I answer that question, I don't believe in the term DevSecOps. To your point, actually, that if security is baked in and built in, it should just be non-existent from a DevOps point of view. So from that perspective, again, just to be clear, what I'm talking about is having an expert be part of the team who is primarily responsible and working with the other team members. I should have been clearer. I'm not suggesting that the developers who want to learn and who are capable of learning about security, certain aspects of security, they should not be prevented from learning. But at the same time, at least in my experience, I've noticed that if you burden them with the responsibility, let's just take the flip case or the scenario of you do not have a security-focused guy in that particular team, of application development or an application operation team. Guess what? Then they have the responsibility, and they're going to make a lot of mistakes. So again, security in and of itself, and I've always said that in order to be a good security architect, you have to be a good application architect, and you have to have that wholesome perspective. And again, when you're talking about application development team, you have obviously a mix of levels of expertise, right? A software architect may be able to understand and may be capable of picking up all the security concepts, but most of the developers would not be. And again, just to throw in there, one of my strong opinions again, given that I'm in the process of doling out opinions. many people, again, this is something that seems to be a fad, at least in the Silicon Valley, that you build, you deploy, and you're responsible for managing it. I don't quite believe it, because then what happens is, again, a young, fresh grad out of school could be very good at building something, right? I mean, building a portion of the code. But he or she may be completely clueless when it comes to deploying and understanding the whole stuff. So suddenly you give him or her a pager and say that now you're responsible for your entire ops-related responsibility. That's not going to work, you know? So I think it's important to have that person who has the, he or she who has the expertise from a security point of view, bringing their security perspective right from the design, right from the discussion point of view. That is what I mean, and I think of it as security being built in and not bolted on. You know. I hope I answered the question. Yeah.
Yes, my name is Pierre Boiron. I am at Sabre. I lead the cyber threat team. You stated in your statement that the application security engineers will never be good at security. But shouldn't security be part of the whole SDLC process?
Yeah, so that is what I was alluding to as I was answering the question. You know, again, just to be clear, I was talking more from the perspective of roles. So if you have in your application development team a security-focused person or persons who are expert in that, and then bringing that security perspective right from the point of discussions, you know, business requirements and functional specification and all that, that is something that becomes part of that entire process, rather than, just to be clear, right? I was not suggesting that you do away with the process, okay? I was suggesting that not burden the application developers who are good at building the business functionality with the additional security-related responsibility. Have an expert, work with them, and be part of that team, you know? One of the things that I've noticed, just to be clear, is that having a separate team that is responsible for all of this, the entire DevOps pipeline responsibility, and having a parallel team, that I've seen in the context of containers and function and how things are changing, they are starting to struggle, you know, because coming in after the fact, I think that is where your question is coming from, that doesn't help, you know. So having a security-focused expert or security expert being part of the team and who is involved in the discussions and bringing in that security perspective, I think that is what I'm suggesting. Again, feel free to try it out if it works. I think I'll be very. I understand where your question is coming from. I'll be very candid and honest here. Is that, see, trying to teach the application developers to build security into the application and not make mistakes, that is something we have tried for 10, 15 years. Again, if that was the case, tools like white source for source code analysis and so on and so forth would not be that popular, right? I mean, there is still source code analysis happening. There are still tools that are available. So my point is just that it's good to have those who want to have that additional knowledge, but not burden them by saying that, okay, this is your security responsibility. Now you have to be able to address all of these requirements that we have from a business point of view, from a risk assessment point of view. Have a dedicated person who can bring in that perspective. And again, when I say dedicated person, I'm not talking about somebody who is a typical GRC or governance, risk and compliance kind of person who is going around and saying that, hey, I ran this tool and you're supposed to fix all these vulnerabilities. That is all good and required. But also being able to understand that, okay, which is why, as I was proposing earlier, that a security person who is, or a security engineer who is working with the application developers need to come from, or has to come from, that application development background. Similarly, a security engineer who is involved with application operators has to come from that background, who has done application operation, who has done the configuration of application in the older context for scalability, for high availability, and so on. Similarly, on the infrastructure side of things, bringing in somebody who has gone through that whole process, that experience, and has learned or has already picked up, or has also picked up security-related chops, have them work with, or have him or her, or how many other people you can afford depending on the size of the team, work with those guys who are primarily focused on either building the application, building the infrastructure, or building the scalability and the reliability aspect of the application.
Good morning, Asif. Thank you so much for your talk. My name is Alex Braun. I'm the CISO at allweb.com. As the containerization is taking more place and immutable infrastructure is being deployed out, how is that actually impacting a company like Qualys, which traditionally does vulnerability scanning in production space, generally speaking, after something has been released and it's accessible, and you're starting to get into microservices? Are you guys seeing a shift occurring where more of the vulnerability scanning is becoming integrated with the traditional CI/CD environment versus production side of the house?
Actually, that's an excellent question, and I'll answer that question. I'll try to answer that question quickly by breaking it down into two parts. So the first thing is, in terms of the approach, let me ask the question which was sort of, I understood in between the lines, right? I mean, in terms of the Qualys approach, or the traditional Qualys approach, which is a host agent-based approach or a network agent-based approach. The network aspect still works, network scanner, but the host agent in the context of, obviously, like I said, in case of AWS Fargate, where you don't have access to the underlying infrastructure, so you can't install the agent. So obviously, we have solution that works into, that provides the visibility as well as protection by being part of the workload itself, all right? So now to answer your question more directly, the first one, in the context of vulnerability, see, the application workload, whether it was bundled in the form of VMs, containers, or now in the form of function, whether something is vulnerable, that has not gone away, right? You're still going to use packages. You're still going to use certain open source packages, which you do not trust completely. So from the perspective of keeping a handle or getting a handle over vulnerabilities, yes, it is getting more and more into the whatever it is being referred to as shift left, is moving to the left, and it is getting built into, or those checks or gates are getting built into the build process, is getting more and more on the build, ship, and run, on the build and ship side. But at the same time, once you have figured out the vulnerabilities in, let's say, in a container image, when it is being built or after it has been pushed to the registry, when you're deploying and when you're running it for quite some time, you still have to ensure that the instance that has spun up is not vulnerable, okay? Or the new vulnerability that has been announced does not impact your running container instances, So from that perspective, it still has to cover the entire life cycle of build, ship, and run. So you have to, from a vulnerability management point of view, you have to have checks in place, gates in place for each of these three phases. So again, as an example, so when you're building your container images in Jenkins pipeline, you have to make sure that the image that is being spit out does not have any high severity vulnerabilities. Similarly, when you are pushing the images into the registry, you have to do the same thing. And when you finally deploy, this is where in the context of Kubernetes, you have something called admission controller and so on. You can have a final gate. And then once the instances are up and running, most of the containers, regardless of whatever people say that they are ephemeral and so on, the average uptime is typically around 7 days or so. So you still have to make sure, even if it is running for 7 minutes or 7 seconds, that it is not vulnerable. So short answer, the shorter version is that you cannot do away with that, and that is the perspective, not just of Qualys, but also of the industry.
Asif, thank you so very much for
Thank you.
sharing your
I went way over.
thought process and ideas. No, you didn't. That's great questions, too. Thank you.